Good day, everyone. I'm Jayakody. In today's presentation, I would like to talk about large-scale in-situ shear testing on waste material at Meethotamulla Open Dump Site. Here is the content of my presentation. Now, I will start my presentation with this introduction to landfill failures. Failures of landfill, although not common, have occurred on a regular basis around the world. As the infamous Meethotamulla base will collapse, claiming lives of people and infrastructure, landfill failures became one of the hot topics in Sri Lanka. In Sri Lanka, as a result of uncontrolled dumping and malfunctioning of waste segregation process, no proper studies have been carried out to determine the shear strength properties of waste material. Therefore, this study was conducted to determine the shear strength properties of MSW. Now I will try to give you some understanding about past studies carried out with respect to shear strength testing on waste materials. As you can see from this figure, Dixon and Jones highlighted that out of many engineering properties, shear strength of MSW can be a vital property for many design cases. Fassett et al. Emphasized on three main factors contributing to the shear strength of MSW. Number one, the organic content and the fiber content. Number two, the age of the waste vat and the extent to which it has decomposed. Number three, the placement conditions. The most widely used shear strength theory in MSW testing is Mohr-Coulomb relationship. To take the tensile strength of the fibrous elements into account, Kolsch added a percentage of fiber cohesion and tensile angle to determine a theoretical shear strength. As you can see from this table, there are three main ways of determining shear properties in the literature. Those are back analysis, lab testing, and in-situ testing. As from this table, it is summarized that each of the items has their own advantages and disadvantages. In this research, an attempt was made to estimate the shear strength properties using in-situ field measurement by fabricating a large-scale direct shear apparatus. Saying that, now I will move into my research objectives and steps followed. The main objective of this research is to fabricate a large-scale direct shear test apparatus to determine the shear strength properties of MSW in Meethotamulla wastefield site. And here are the steps I have followed in the study. I will describe each in turn in the next few slides. The number one is fabrication of large-scale direct shear test apparatus. The apparatus shown here was designed by Miyamoto et al. Has dimension of 300 mm by 300 mm in plan view and 150 mm in height. They have shared the specification with us during their visit to Sri Lanka after the Meethotamulla failure. After successfully fabricating all the parts as shown in here, we have conducted the calibration test. We have conducted calibration test on load cell, normal load to normal stress conversion, and the data acquisition system. Afterwards, we planned our test on 4 different degradation levels. In the absence of collection data, it was assumed that different heights on the waste mount will give different degradation levels. Accordingly, 4 tests were conducted on 26 meters, 22 meters, 14 meters, and 7 meters. After those 4 locations, we have carried out waste composition analysis at that and those locations. As this table shows you the waste composition analysis, we carried out the framework proposed by Dixon and Lanka. There are no significant variations of materials at different locations, and this may be due to the ad hoc nature of waste dumping system which was practiced at the site. Further, biodegradable items were not found at the time of tests were carried out. Now I will move on to the experimental program carried out at the site. In-situ testing program was started with sample preparation. After sample was successfully prepared, shear apparatus was placed very carefully without harming to the sample. Then we applied the normal load and kept for some time until we see no vertical deformation on the sample. Afterward, shear load is applied using this jack. Rate of shearing was maintained around 1 millimeter per minute. However, the shear rate could not be kept exactly at 1 millimeter per minute as a consequence of the manual controlling system. Then the sample is sheared until the shear displacement reaches 45 millimeters. Now I will move on to the results of the in-situ testing. The tests were performed under the conditions of 3 different normal stresses. Those are 10, 20, and 25 kilopascals. These curves exhibit similar behavior where none of the curves has an identifiable peak position. We observed parallel increase of shear stress over the displacement as suggested by many researchers. After in-situ tests, an attempt was made to observe the shear behavior after removing the waste particles greater than 10 mm in the laboratory conditions. That is, shear tests were carried out on remolded samples, and here are the results of those. Now I would like to talk about the findings of these shear tests. The mobilized shear angle is in the range of 36 degrees to 39 degrees for both in situ and laboratory tests. Mobilized cohesion is 16 kilopascal for location 1, 2, and 3, and the cohesion value for location 4 is 9 kilopascals. However, there is no cohesion in the laboratory test sample. This may be as a result of removing the lengthy particles. Now I'll be moving to the more discussion on my tests. This figure shows the variation of friction angle with the shear displacement. As you can see, the mobilized friction angle ranged between 12 degrees to 45 degrees when the shearing displacement varied between 18 millimeters to 36 millimeters. Therefore, it is quite vital to have a limiting condition to shear stress properties when it comes to designing of landfills. Here, the results obtained from the in-situ direct shear test were plotted on the graph suggested by Manacero et al. The result obtained in study do not match with the trend line in zone A, which represent the applied normal stress below 20 kilopascal. As 25 kilopascal was the maximum applied normal stress used in this test, a validated prediction cannot be done for zone B and C. Now I will move into the conclusions of my study. A large-scale direct shear apparatus was fabricated and shear strength properties of MSW at Meethotamulla Wastefield site was studied. To assess the shear behavior, samples were selected at 4 different heights, representing differently aged locations in the Meethotamulla. However, it was determined that 4 different locations have more or less similar waste constitutes. The normal load applied in these tests were 10 kilopascal, 20 kilopascal, and 25 kilopascal. A peak failure state was not observed during in any of these tests. Therefore, 10% strain was considered to define the Mokulov envelope. However, it is a much needed requirement to do the shear test for higher normal stress values with mechanism to measure the normal stress applied to the system. The results obtained from the in-situ direct shear test on MSW are in line with some of the previously published data while contradicting to some research findings as well. And more repetitive tests and results are needed to make strong agreement between the already published data. These are the references that I followed in this paper. Thank you for your kind attention. If you have any question on this, please reach me out using these 2 emails. Thank you very much.